Welcome dear students. In this video lecture we are going to solve a projections of solids problem in our problem set, problem number 6. So we are working with projections of solids problems under the category solid axis inclined to HP and parallel to VP. In this, so far we solved 5 numbers of problems, and now the problem number 6. The problem is a cylinder of base diameter 60 mm and axis 70 mm is resting on HP on one base point such that the axis is parallel to VP and 45 degree to HP. You have to draw the projections of the solid, and here we are ready to solve the problem. And not like the previous solids that we already solved number of problems from the solids of polyhedrons. Now we are going to solve a problem on a solid of revolution, that is a cylinder. Cylinder is having a circular base. The solid cylinder is having no edges and no corners. It's completely different when you compare with the previous solids. And here let's start to solve this problem. Let me to draw the XY line. Yes. Like the previous solids problem, here also first we have to decide where to start the answer. That is the base view of the cylinder, a circle, where this will be drawn, whether in front view or in top view. That's based upon the axis condition of the solid, as we already know. So here the solid cylinder is resting on HP by its one of base point, and the axis is inclined at 45 degree to HP and parallel to VP. So in order to see the base view of the solid, we needed to make the axis perpendicular to HP. It's very easy to make the axis perpendicular to HP instead of making it perpendicular to VP. So for our convenience, we are making the axis perpendicular to HP. So in this condition, automatically the base view circle of the solid will be obtained in the top view. So let's start the problem from the top view by drawing the base view of the solid circle. The dimensions of the cylinder are given as the diameter of the base is 60 mm and the axis height of the solid is 70 mm. And this solid is going to rest on HP on one base point. You can look one thing, one base point. Since there is no base corners, base edges in the solid cylinder like the previous solids polyhedrons, here the resting condition of a cylinder can be mentioned with the term with one of its base point. For example, once you think about the resting condition of a cylinder in any surface, maybe it may be in HP or in any surface. If a cylinder is resting on a flat surface, the point of contact will be the manner of contact will be a point contact only. That's why in this problem the cylinder is made to rest on HP with a base point. This is the one and only choice, and apart from that one more choice is there, that is you can rest a cylinder on the flat surface in this flat manner. If the cylinder is resting like that, the nature of contact will be line contact. This can be happen when a cylinder is completely lying on a flat surface, or it's maybe completely sticking on the vertical surface. In both the cases, the line contact may appear, and now the type of contact is point contact, since there is no complete laying of the cylinder on the HP. It's just standing in a tilted manner with its axis inclined at 45 degree to HP only. Let's draw the base view of the solid. The base view of the solid here is a circle in the top view. And now, for our convenience, we are going to separate this circle into 8 number of equal parts as sectors. I already told there is no corners to be named in this circular base, but for our drawing purpose we can mark the generator points in this circular base. First we need to split this into 8 equal parts. For that, very similar to the work we performed in the chapter cycloids, involutes, to split the circle into 8 equal parts, here also we can follow the same procedure. After splitting it into 8 equal parts, you can mark the generator points by marking alphabets and numerals in the base and the face respectively. One more time I am telling you that they are not corners. Okay, they are generator points. For convenience only we are making them. The same way for the face. Since the base points are invisible when you look from the top, I am giving bracket to them as usual. And then let's draw the projector from each and every points from the base view towards the front view. After projecting them, the axis height, up to the axis height we have to estimate the solid. The axis height of the solid given in the problem is 60 mm. let me to draw the pilot line with a 45-degree inclination in order to make the lateral view inclined at 45-degree to HP. Now, as usual, I need to draw the projectors from the front view towards the top view. Now, identify the cut points like in the previous problems. A, B, C, D, E, F, G and H. In the case of face points, starting from 1, 2, 3, 4, 5, 6, 7 and 8. Now, in this cluster of points, as per our regular rule, we can connect and complete the points. The rule is, the first rule, you have to join all outermost points as visible curves or generator. Since it is a cylinder, there is no edges are there, so the base and face points can be joined as curves and the lateral generators will be joined like edges. And the second point is how to join all remaining face points as as visible curves. And the third point is how to join all remaining base points as invisible curves. Now look over. I am going to join as per the rule. the base points starting from the outermost base point starting from G, H, A, B up to C can be joined as visible curves, and the points G, C and 3 are the generator point. This has to be joined as straight line. Since it is a lateral generator, I have to connect it as a line. And then the portion 3 to 4, 4 to 5, 5 to 6, 6 to 7 can be again joined as visible curve. This can be performed by freehand first and followed by French curves. And the portion 7 to G can be joined as straight line. And now the rule number 2 is how to join all remaining face points as visible curves. So here starting from 1 to 2, 2 to 3 and 1 to 8, 8 to 7 can be joined as visible curve. And join all remaining, the third rule, join all remaining base points as invisible curves. The remaining base points are starting from C to D. They should be invisible, so I am using dashed for a curve format in order to highlight it an invisible portion. Now the work is over. You can try this with the proper tools in your A3 size paper. Thank you very much. And one more point here, you can note that the outermost generators only need to be highlighted by the pencil with the HB. And in the first simple projection, the 1 dash and A dash are the outermost generators and 5 dash E dash. These two generators are highlighted, and then in the third stage also I highlighted 1 dash A dash and 5 dash E dash. But you compare the same with the final top view. Here the outermost generators are 3C and 7G. These two only highlighted with HB pencil and not other lateral edges. In the case of solids of revolution, that is in cylinder or in cone, the outermost generators only need to be highlighted, and they have to be treated as like edges and not all the generators. In the final top view, you need not to highlight them 2B and A1A, 5E, 7G and 8H. You need not to highlight the rest of the interior generators. You need to highlight only the outermost generators as similar to an edge. Note this point in the case of cone and cylinder.